All right, today is Monday, December 12th, and I am at the board office today. So you will be having a video lesson. There's going to be two parts. So I'll have both links right here. And we will have our Unit 7 test Wednesday, December 21st. So this is the first day of this new lesson and unit. If you have yet to pick up a booklet for sequences in series, then please check out the teacher's desk on the left-hand side. There's a whole bunch of booklets in a box. Just make sure you grab the right one. So you're looking for the arithmetic sequences as your first page. All right, so make sure you have day one in front of you, and we're going to get started on the lesson. Okay, so the first thing we're going to look at today is arithmetic sequences. So arithmetic sequences are something considered like this. So consider the sequence. We have 3, 5, 7, 9, 11. Can you kind of guess what the next terms are going to be? And then what number must be added to a term to find the value of the following term? Okay, so if we have 3, what value was added to get 5? And then 5, what value is added to get 7? And then so forth. Well, if you guessed 2, you're correct. If the number added is added, then we have this consecutive terms that are happening, and it is considered an arithmetic for adding arithmetic, or subtracting, could be adding or subtracting here. So if the number added to find the value of a consecutive terms is always the same or constant, so you're always finding that 2, right, or it's always jumping by 2 or adding 2 each time, this is considered arithmetic, and it's a sequence. A sequence has commas in between as well. So we have commas in between our values, and we're going up by 2 each time. So this fixed addend, which is called a common difference, or what we consider the letter D. So the symbol for this is the lowercase d. The common difference, or D, can be found by subtracting the terms. So what I like to do is I like to take the second one and then subtract the first one, and you get your common difference. Or the third one, subtract the second one. So for instance, here we can see that we have a whole bunch of terms here. Let's go and identify what they are. So number 3 actually stands for the first term, but we don't call that just number 1. We actually call it T with a subscript 1. So that's our first term, T for term, and then it's number 1 is a subscript. This would be our second term. This would be our third term, fourth term, fifth term, and you get the kind of gist of it until we get to Tn. That would be our nth term, or the last term. All right, so let's go find the common difference. We're going to take T2 and subtract it from T1. So 8 minus 3. We can see that T2 is 8 and T1 is 3. 8 minus 3, we get 5. What about T4 minus T3? We could even do the same thing with T3 and minus T2. As long as you're taking the second term after whichever term you've decided to look at and subtract them, you're good. So they've got to be the ones that's side by side. So it's, you know how you do like first differences? It's just like that. So here we get 5 again. And if we wanted to look at T5 minus T4, so this would be 23 minus 18. Again, we get 5. Okay, first differences. This looks linear. But anyways, it is linear. When we're looking at something that's arithmetic, it's going up by adding or going subtracting, we could say, too. These are all kind of like linear steps that are involved. Let's look at this one. So we go from 5 to 7 to 9 to 11. What does it look like we are having for a common difference here? So from 5 to 7, again, we get 2. This is 2, 2. So then here we'll get 3, 13, and 15, where the common difference is 2. And then for these next ones, so again, watch out for here because it's not the difference between 15 minus 12. This is, we're looking at 12 minus 15. So this we get -3, 9 minus 12, we get -3, and 6 minus 9, -3. So here we'll get 3 and 0. So our common difference here is -3. Okay, go ahead and try the next two out, and I'll help you out with the last two. So for this one, we should have got a common difference of 0.6, which leads this to be 3.7 and 4.3. And this one over here, you should have a common difference of -3 again. So this is -14, and this is -17. For this one right here, it's just fractions that we have. So again, it's 2/3 subtract 1/2, and we get 1/6. So the common difference, here's 1/6, so then we would add 1/6 here, so we get 4/3 and 3/2. Those are just reduced fractions. And then this last one, let's go ahead and check to see what the common difference is. So we have 2p plus q, and we are subtracting that from p plus q. All right, so 2 minus 1 is 1, so we're going to get 1p, and q minus q is, there's no q's. All right, so then that means we are adding 1p every time. So this one, so our common difference here is p, so that means we're going to have 4p plus q here and 5p plus q here. The q just keeps on following along, and the p is the one that increases in values. All right, which of the following are arithmetic sequences? So beforehand we were looking at all arithmetic sequences, but here there may be some that are not arithmetic. All right, let's go and check. So we do 5 minus 1, that's 4. What about 9 minus 5? 4. Okay, and if you're getting them all to be the same, then yes, it is arithmetic. So this one is, and we get a common difference of 4. Let's check this one. 2 minus 4, we get 2. 7 minus 4, we get, nope, automatically it is not arithmetic. Let's check this one. 1 minus 2, 0 minus 1, -1 minus 0. Yep, this is a common difference of -1. So yes, this one is arithmetic. What about this one? -3 minus -6. 0 minus -3. Yep, we're getting 3 every time, so a common difference of 3. This one, 71 minus 76, 66 minus 71. Yeah, a common difference of -5 every time. And this one, 1/3 minus 1/2 and 1/4 minus 1/3. No, that is not a common difference. It's not the same. It's not arithmetic. It doesn't have a common difference. Okay, so let's look at a couple of these questions. So the first term in this arithmetic sequence that we're looking for is 15. So that's called T1. Let's call that T1. T1 is our first term, and it's 15. And the common difference is -4. And we're just asked here to list the first 4 terms. All right, so our arithmetic sequence, and it's telling us that it's arithmetic sequence, so we're going to have 15. What do you think the next number is going to be if we have to have a common difference of -4? If you guess, just subtract 4, you're right. So this is 11. Subtract another 4, we get 7. Subtract another 4, we get 3. And we can see here this was T1, T2, T3, T4. Awesome. That's it. The first term of the arithmetic sequence is A, and a common difference of D. List the first 5 terms in the sequence. So it's telling us the first term, T1, is A, and we want to have a common difference that's called D. Okay, D is equal to A. All right, let's go ahead and check these terms. So if we have T1, we know it's going to be A. And it's saying that the common difference is D. So that means we're going to attach D to the next one. So this will be A plus D. This would be our second term. Beforehand, we subtracted because the common difference is negative, so it's going down. But here, a common difference is positive, so we should be increasing in values. T3. So T3, we're going to add, here we added on to a D, and then we're going to add another D. If we add another D, that means we have to D. Our term 4 is going to be A plus another D added onto it. We get 3D. And term 5, we're going to have A again plus 4D. And so on. It keeps on just going on and on, but we only have to list the first 5 terms. All right. And again, at any time, please press pause, rewind, fast forward, wherever you would like. So from the answer above, you can see that the first 5 terms of the arithmetic sequence are listed here. Let's go ahead and list 6, 7, 8, 9. So here we'll have A plus 5D, A plus 6D, A plus 7D, and A plus 8D. How does the common difference compare to the term number? Did you see any connection? Like this is 1 and this is 0, this is 2, this is 1, this is 3, this is 2, this is 4, 3, 5, 4, 6. Yeah, it looks like it is 1 less, right? It looks like it's 1 less. If that's 8, that's 7. All right, so the coefficient of D, or common difference, is 1 less than the term number. All right, so we get this formula. This formula is T at n, which is our general term, is equal to A, or whatever term you're looking for, right? This could be your last term, it could be your first term, it's whatever number you want to put in for n. So T at n is our general term that we're looking for, is A, the first value, plus n minus 1, the term minus 1, times your common difference. All right, so let's use this formula and discover what T12 is in this case. All right, so we're going to identify each of these terms. So first of all, we're going to start off with our A value. Our A is equal to 3. That's our first term. We can now figure out what our common difference is. So what is it going up by? So you take 8 over to the side, you do 8 minus 3, and you get your common difference is 5. And then maybe let's try the next one too. 13 minus 8. Again, we get 5. Perfect. It's common difference of 5. Next, we need to figure out what we want. And we want here is n to be 12. We want to find the 12th term. So that means n is 12, and we're trying to find t at 12. All right, so t at n is equal to our formula, a plus n minus 1 times d. Let's sub everything in. So n we're going to have as 12. So n is right here, so it would be 12 in the lowercase, called the subscript, as well as an uppercase 12 right here. So we're going to have 3, which is our first value in our sequence, plus n, which is 12, minus 1. So n we can find here, which is 12. Minus 1 is from the formula, and then d is 5, and we found that by looking at our first value and our second value and subtracting our second value from our first value to get the common difference of 5. All right, let's go figure this out. So we have 3. We're not going to do anything here yet. We're going to figure out what's inside the brackets first. 12 minus 1 is 11, and then here we have a 5. Again, we do not add 3 and 11 first. We have to multiply by 11 and 5 to get 55, and then we can add on the 3. So we get 58. So our 12th term is 58. So therefore, t at 12 is equal to 58. And that's all the time I have for this video. Please go and check out part 2 in the next link.